Okay, so let's do this. So what are we learning about tonight? We are learning about something called the sine rule. And what the sine rule allows us to do, which is very helpful for, is situations where we don't have a right-angled triangle. So if you look at this first triangle that I'm starting with today, if I want to find the unknown side x, we have a bit of a problem because grade 10 trigonometry uses the SOHCAHTOA idea with ratios and a 90-degree angle, but we don't seem to have a 90-degree angle here. Let's just make sure though, can you find me this angle over here? So everyone, if you could just find me what that angle is using what we talked about in the last lesson. Okay, and I think most of you know that to get that missing angle, all that you had to do was go 180 minus 48 minus 37, because that's the sum of an angle, sum of angles in a triangle. So that's 95. Okay, so here's the thing. You don't have a right angle in this triangle, and so you need a new tool to help you. Now, the proof of why this rule works, I'm not going to cover today because the focus is more on practicing. But basically what the rule does, the proof does, is it divides this triangle up into two right-angled triangles. It almost cuts it in like that. And then using the fact that you have two right-angled triangles, it kind of creates this rule called the sine rule. Now, I'm just going to show you how to use it. So this is how you use the sine rule. You write down the unknown side in a triangle, and then you look at what's opposite that unknown side. And what's opposite that is 48. And so what I do now is I write down the sine of 48 on the one side. Then, in order to use the sine rule, you need another matching pair of sides and angles. And the other matching pair is going to be this one. And we write down the side on top, and we divide by the sine of 37. And this equality will hold. So a side divided by the sine of an angle opposite is equal to a side divided by the sine of the angle opposite that. Now, what do you think I'm going to do to get x all by itself using this idea so far? Because normally when we solve equations, how would we get that x by itself? Yeah, I think cross multiply. And so we'll cross multiply, in this case, by the sine of 48 over 1. Or you could just say the sine of 48, but, And what will happen if you do that is you will get this thing over here. X is equal to 23 times the sine of 48 over the sine of 37. Now, a lot happened there, so let's just reverse for a second. We said the unknown side that we were looking for divided by the sine of the angle opposite is equal to the other side divided by the sine of the angle opposite that. Then we multiplied both sides by the sine of 48, and the whole reason we did that was to eliminate the sine of 48, which then leaves us with an x. Now, we need our calculators to help us here, but can you help me find the value of x that, basically is the length I was looking for? So pop that in your calculators, and what do you get? So 23 times the sine of 48 over the sine of 37. And you should get 28.40 centimeters. And that makes sense because 37 is a smaller angle, and that side is smaller than the final answer you got here, which was 28.40 centimeters. So it's really actually not that tricky to do this. And so we need to practice this, but give me a thumbs up if you followed what I was doing. Give me a thumbs down if you didn't, just so I can get a feel for the room. Okay. So officially, Bongani, we're going to do another one now in a moment. So I will do another one now. In terms of mathematically expressing the sine rule, the way it looks in fancy mathematical language is a side over the sine of the angle opposite is equal to the side over the sine of the angle opposite that, and so on. But that's the one way. When we're solving for sides, we write the sine rule like that. When we are solving for angles, we write the sine rule like that. Can anybody spot the difference? Can anybody, maybe somebody can come on and tell me what's different between the two different statements of the rule? Who feels like they know what the difference is? Okozelu, let's unmute you and you can tell us what you think is different.
Hi, sir.
Hey, what do you think's different?
So for the first one, sir, I think you use it to find the sides, like when you're giving the angles and then you have to find the sides. And then for the second one, you use it to find the angles.
Perfect. And do you notice that when I'm finding sides, the sides are on top? When I'm finding angles, the angles are on top.
Yes, sir.
Perfect. Thank you so much. Quite right. So basically, these two statements of the rule are the same. It just makes life a bit easier if when you're solving for angles, the sine of an angle is on top, whereas when you're looking for sides, we put the side on top. Okay, enough about that though. So over to you guys. I want you to tell me, there was two parts to this. If we look at that, I'm going to write x to start with. What do you think is going to be below that x? What do you think is going to be below that x? So it's not going to be just 115. It's going to be the sine of 115. Yes, because these two are a matching pair. And then here, what is the other matching pair? What's the other matching pair that's going to fill out the space here? So it was a side on top here. So what should go here? I think it's going to be the other side. And then I get the sine of 48. Okay. But now I want you to think, what is the value of x going to be if I have to move things around and get a value for x? What's going to be the value of x, the length that I'm looking for? What do I have to do in order to get the x by itself? I think I just have to times both sides by the sine of 115. And so then I should get, in my calculator, I type 11 times the sine of 115 divided by the sine of 48. So there seems to be a bit of a debate. Let's just make sure that we are all getting the same thing. I can also share my screen if it's helpful to show you the calculator at the same time. Let's see if I can get rid of that. Yeah, move that across. So what we should be getting is we go 11 times by the sine of 115. Actually, I probably would have put a fraction in first. So 11 times by sine 115 over sine 48. Go to the end, and we get 13.3 13.42 centimeters. Looks good to me. Yep. Okay, so it's actually using the sine rules actually not that bad. So let's do some multiple choice questions around this idea just to make sure you're on the right path, but it's looking good so far. So here's your first multiple choice question. You're given a triangle that looks like this. The unknown side that I want to know is x, but they don't ask you for x. They ask you what equation setup goes with this shape. And see if you can identify what goes with this shape here. So because I'm solving for a side, I know x over the sine of 54. And then what matches with that? I guess I need another side. And then I need the angle opposite that. Which one matches that? Everyone seems to be saying C. Do I agree? Yep, I agree. C is the correct answer. Well done, everyone. You are getting the sine rule chop, chop. Chop, chop. Let me see if I can find a harder one for you. So in this one, the first step is given, right? So they tell you this is true, and you have to find the option that gets the x by itself. So which of the four options would be the correct step to get the x by itself? Cheapest people like C's in this place. Let's see if I agree. I know I'm going to times both sides by sine of 54. And I'm looking for a times. Okay, so it can't be those two. And it can't be A because it's the wrong way around. It should be 12. So this has to be the correct option. I see. Yes. So C is correct. C is correct. I feel like I'm not rising to the challenge here. I need to give you something a bit harder. Let's see. Can you do this one? This looks a bit more interesting. So you are given this drawing, and you have to find which of these statements matches solving for B. Let's see if it's C again, or it's something different for a change. Now ask yourself, what am I trying to find? B over sine of 56 equals what? 5 over sine of 80. I'm hearing a little bit of audio feedback. So maybe we can hit mute all again, just in case. I don't know why. Maybe somebody came on afterwards and they haven't been muted. That could have happened. Cool. So what do we get? Everyone seems to be saying B. I agree. B is the correct answer. And so we get B, because the sine of 56 basically moves from here and becomes on that side. So for Tekel, what I did was there was a sine of 56 at the bottom, and what it looks like is that those two get cancelled, and then this sine of 56 reappears on this side. And so there's my 56 over here. Here's my 5, and there's my sine of 80. Okay. Let's go. We're actually almost ready to move on from this, but let's just see if you can do more ones by yourself. So what is the length of side A in this question? See if you can do that. And then I'm going to keep an eye on the chat to see if there are any more questions or comments from the students. But I know Hugo is a ninja on the keyboard, so. Okay, Cass, so you voted for that, but not all the same. I don't know what the answer is. I'm going to have to work it out, but let's see. A over the sine of 54 is equal to 3 over the sine of 27. And then I want to move this thing to the other side. And I'm going to get 3 times the sine of 54. And let's see if I can put that in my calculator. So fraction. Do that. Sine of 27. That. And I get 5.346, which would be B. So B is the correct answer. Okay. I feel like I need to challenge you guys. Let me see if I can find one from later on that I feel like I'm not bringing the whole. Here we go. Here we go. Is this to that one over there? Oh, but we need to use the cos rule for this one, I think. Or do we? No, we don't. Okay, you guys are doing so well. I'm going to take it up a notch here just because you guys are smashing it. So Farmer Jones has a triangular field ABC. He wants to fence the field. Fencing is sold by the meter. How many meters of fencing does he need to purchase? Okay, now, what this is saying is you need to find the length around the whole triangle. Who has some suggestions about where we need to start? You can put them in the chat. We have to decide which of the 4 options are correct. You have the sine rule to help you. Where do you think we should start by figuring out? Okay, so Impor and Kat have said, look, let's find angle A. So you guys tell me, what is angle A going to be? What is angle A going to be? Let's find that first. Okay, so A is going to be 39 degrees because of sum of angles in a triangle. So we'll put 39. Okay, let's start by finding BC. What do you think we can do to find, well, I'm going to let you find me BC. What is BC going to be equal to? I'll let you think about that. And if you found BC, well, what's the other side you still need to find to help you with your fencing problem? So I want BC, and so I'm going to say the sine of 39, and then I'm looking for a matching pair. Which sides do I have a matching pair of a side and an angle opposite that with you to help me? Yeah, vertejo the 300, exactly. And what's opposite that? Well, opposite the 300 is the 27. So I want to know, what value of BC are you guys getting? Yes, Gebotso, I agree. What value of BC are we getting? Okay, so 415.86 seems to be what we get for this. And now you have to find AB for me. And then once you found AB, that should be able to help you to decide which of these 4 options is correct. So see if you can find what AB is.
Keep up the good work, guys. I see these answers coming in the chat and they all look perfect. So well done. Keep going, guys. You're doing excellent.
I think everyone's nice and fresh after their holidays. Their brains are, they come back.
I think so too. I think maybe they're a bit excited even to see some sine again.
Okay. So AB over sine 114. So AB over sine. Now what? Now I think I'm going to go with the original one. I could have used the other side, but why mess with a good thing? So what is my AB going to be? AB is just going to be 300 times so what are we getting for AB? So we could say 300 times sine 114 over sine 27, and I get 603.67. And so my perimeter is going to be 603.67 plus 415.86 plus 300. And what are we going to get for all that? Indeed, I can see that. So it actually, Shante, in this question, there is no base and height in this question because the height of a triangle is always perpendicular to another side. Okay. So well, let me see if I add up. So if I go 603.67 plus 415.86 plus 300, I get 1319.53. Oh, but you would round up. Okay. You know why you get C is because if you look at the rounding, so I would imagine some of you go for C and some of you go for D. It depends how much rounding you would do. But if you round to the nearest unit, D would be the correct option because it comes out as 1319. So 1319.53. And so that rounds up. Okay, so that caught some of you. Don't worry, you got most of it correct there. I didn't actually look very closely if it was 0.67 or 0.68, Rafense. I'll have to go, oh, it's 6.8. It's actually 6.8 because it's on my calculator. You're quite right. It's 6.8, which makes that 6.8, which will make that even bigger. And so it's still going to be D as the correct answer. Okay. Awesome. Okay, so in the first part of the lesson, you learned how to use the sine rule to find sides. And we even did a combination question, which was great. In the second part of the lesson, we're going to use the sine rule to help us find angles. But in order for our brains to absorb that, we need to click Save As and take a break. And so what I want you to do is I want you to turn on your cameras. I want you to stand up with me. And Hugo, this is a bit different. I don't know if anyone else does this, but I insist they do some exercise so that their brains have a break. And so I want cameras on and let us stand up. And what I want to do is I want to start with just loosening it up. So pretend you're like a piece of licorice and just let your arms flop about for a bit. And then take your legs, kick them out a little bit. Okay. And what I want you to do is start by rolling your shoulders. So roll them back. 1, 2, 3, 4, 5. Roll them forward. 1, 2, 3, 4, 5. Okay. Then I want you to do a tricep stretch. And while you're doing a tricep stretch, I want you to look into the distance as far away as you can. Give your eyes a break. You've been staring at the screen. We want our eyes to focus somewhere far away. And then I want you to switch to the other elbow, and I want you to look somewhere else that's far, far away. So you're taking care of your eyes there. Okay, loosen it up, shake it out. Then let's do a stretch like this. Okay, 1, 2, 3, 4, 5. And then let's stretch the other arm. Okay. All right, this next one is kind of a little bit of a rhythm one, or not too much, and it's a breathing exercise. And the way it goes is you go a deep breath in, breathe out. Okay, so it's a combination of breathing and rhythm. So let's do it together. One more. Okay. Then for the final thing for tonight, some heart rate raising stuff. We're going to do some air skipping. We're going to do 20 of these air skips just to get the blood and oxygen moving. And we're going to start in 3, 2, 1. Let's go. 2, 3, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 20. And then have a seat. And hopefully the breathing and a bit of movement, your brain is feeling a bit better in terms of you've forgotten about all the maths and your brain is being cleared for the next part of the lesson. And let's just do a little brain break before we get going for part 2. So I want to know, what is a lemon plus a watermelon plus a peach or an orange? See if you can solve that. So for Teco, exercise and breathing is a very important part of learning, as is eating, actually. So these are all little things that if your body is frustrated, you're not going to learn nicely. This is one of those things. So that's why I always encourage my students to move around, even if they roll their eyes at me, which does happen in the classroom. But yeah, I believe in it strongly.
I really think, Teacher Peter, that's a very good idea. But in the grade 7 class where I'm from, I'm afraid if we have them stand up and do movements, we're not going to get half of them back again.
No, I think it is an age-related thing. Yes, absolutely. No, that is true.
But it's an excellent idea. I enjoyed it a lot.
Cool. I'm glad. Yeah. No, it is. It's okay. So let's see what we get here. So we get 3 for the apple. I think that's correct. Now, what's next can we do? So red apple is 1. Yep. And now, where else do we have red apples? What can we do next? Have I missed something? Watermelon is 7. How do we know the watermelon is 7? Oh, because we know that this must be 5, hey? So then watermelon is 7. We still haven't got the final answer at the bottom. What's that going to be? So this is going to be 2. And then because it's plus, Iko and Okanele, you are quite correct. It's going to be 14. Yeah, cool. So this is just kind of like a simultaneous equation, but It's a nice, fun little activity. And the more you do of them, the more you understand the logic of how they all pair up. So I hope you enjoyed that. Cool. Let's get back to the second part of the lesson. So in the second part, sorry if you got dizzy there. What we're going to talk about is we're going to focus more on writing the sine rule in the second way. And the second way has the sine of an angle on top. And we generally use it when we're trying to find an angle. So what would a situation look like where we are trying to find, use the sine rule like this? So let's have a look at this question. If we look at this question, we're given two sides. So we're given a green side, let's say, and a blue side. And then we're given one angle, and we're asked to find another angle. And we can use the sine rule to do this. We just have to modify our equation a little bit. So you start by writing the sine of the angle you want. And then what do you think is going to be below that? What do you think I'm going to write below the sine of y based on what you've seen for the sine rule today? Yeah, it has to go with its partner over there, 10. And then what's going to be on the other side? So you're quite right, it's 10. What's going to be on the other side? So I guess I need another. So on the top, I'm going to write, now again, remember that if you write the angles first, you have to keep the angles on top. So you go the sine of 64, and what matches with the 64 is the 15. Yes. Okay, so this is our trig equation. And what we really want to get by ourselves, or get by itself, is the y. But there's something getting in the way. It's this 10. How can I deal with this 10 in a mathematically suitable way? What would you suggest? And I can't do anything illegal here. It has to be above board. But how can I get the 10 out of the picture so I can focus on the y? Yeah, in some ways, this is kind of easier. You just multiply both sides by 10. And now we have the sine of y is equal to 10 times the sine of 64 over 15. All right, next problem. I want the y by itself, and at the moment, I have the sine of something. How do I undo sine? If I want to, what undoes sine? Inverse sine, yes, the inverse operation. And so what I need to do is I apply, basically on your calculator, it looks like this, the sine of -1 to both sides. I've run out of room there. Apologies for the, I'm trying to draw yourself attention to that. And what we then get is we get y is equal to the inverse sine of this whole fraction. And that whole fraction, just to focus your attention, is that. Now, that is a bit of a mouthful. So have a go and see if you can get the angle y by yourself. Once you've had a go, I will illustrate how I would do it on the calculator. Okay, but see if you can get it by yourself first, and then I'll come along and help you. But basically, to find the angle, we use inverse sine. So shift sine, that gives me my inverse sine, and then I need a fraction inside that. So we get 10. And that's over 15. Close bracket. And now the question is, what do we get for y? Give a bit more time for answers to come through. How did I get inverse sine? I went shift and then I hit the sign. It's that yellow sign to the -1. So I went shift and then sign. And if you have a sharp calculator, it's very, very similar to this. Okay, I get 36. So y is equal to 36.81. Or going back to the original part of the question, this angle is 36.81 degrees. Give me a thumbs up if you followed that example. Give me a thumbs down or a question if you want me to clarify one of the steps, because the next part of the lesson is going to be you doing it by yourself. And so, yeah, I just want to see if you are feeling okay. Okay, well, let's do it. Okay, before we do another full one, let's just do a couple of multiple choice questions, and then we'll get back to it. So, if you are trying to find the angle Y in this drawing, which of the four options here would be the correct way of setting it out? Which of the following would be the correct way of setting it out? I know it's going to start with that. And actually, I can see that it's going to go with the sine of 34/8. And so it has to be that one. Yeah. So the important idea that I try to stress in class is when you're finding angles, you write the sine of the angle on top, because it's easier to get the answer that way. If you do it the other way, it's not wrong, but it just takes longer. And you know, being efficient is part of being good at maths, I guess. It saves you time and all that good stuff. Okay, what about this one? If you are given the following trig equation based on this triangle, what would be the next step that you would need to do in order to get the correct answer? What do you think would be the correct one for the next one? I feel like A is so bad, there's no way A is true. And I don't think C is true either. But B or D both look tempting. What should I be looking? Akonele, let's go to you. What is your question? Can we just unmute Akonele? I don't know if maybe that was a stray hand. Don't worry, Akonele, that's fine. Okay, so if I look at this, sine of 34/8, this has a 7 on the top and a 7 on the bottom. It feels like there should only be a 7 over here, so that would be a D is the correct answer. Yeah. Because the 7 has to move across and it becomes times by 7. Whereas this, there shouldn't be two 7s, like one here and one there. B is wrong because there shouldn't be a 7 up here and down here, because then they would cancel each other out. And then the correct answer is basically to bring this 7 to the other side. Yeah. And then you should have the 7 over the 8. Yeah. Okay, I feel like we should get, let's do another one. So we're basically going through all the steps we need to follow. So of these, if you're given this is the correct answer, so this is the correct answer, what is the next step that you need to do after that to get the Y by itself? And then it seems like people are scanning for the important information, and the important bit is to notice that this is the inverse sine function. And so it has to be B. But now I want you to use your calculator and find me the actual value of Y. So I want you to use your calculator and find me the value of Y that fits this triangle. What is the value of y that fits this triangle? And how would you type it in your calculator? So you need the inverse sign, and you need a fraction. So what do we get if we pull the trigger? So the reason I know I should use inverse sine for Tekel is that I'm solving for an angle. So at the moment, the way it stands, it's the sine of y, and I want to get rid of the sine of y, and so I have to use inverse sine on both sides. Okay, that's why. So what do we get for my answer? We're going to get 29.29. 29.29, which is this angle over here. And also notice how once you've got two angles, you can always get the third angle by the sum of angles in a triangle. So the moment you have two, you get three for free. Okay, I think we are ready to fly solo. So find me the size of angle ABC. And ABC is literally just this one over here. So over to you guys, find me angle ABC. I'm just going to grab some water quickly, and I'll be back now.
Keep up the good work, guys. You are doing excellent.
So what are our answers going to be for this one? I suppose we should start at the beginning by just writing out that would be my first step. So the sine of the angle I want, I've called it B instead of ABC, but that seems reasonable. And then I want the angle on top. So I go sine of 60 over 18. But there's still a bit more work to be done from that point. Let's see what we get. So what I get for beta is 74.21 degrees. Okay. So again, let's have a quick little vote. Thumbs up if you're finding that the second way of applying the sine, it makes sense to you. Thumbs down if you still feel like I'm going a bit quickly. Just helps me gather kind of for this last little bit how much I increase the difficulty and stuff like that. Or if I just rather stay kind of where we are right now. Okay, well, let's do another one. We need a bit more. We're getting there, but we're not quite perfect yet. So I want you to find me the angle Y. Find me the angle Y using the sine rule. Pop those answers in the chat there. Okay, now you can't just write y, you actually have to write the sine of y. And then we write so I'm not writing in the inverse sine here, but that is the step that you need to do. So inverse sine, fraction, and you should get 40.14 degrees. Yeah, so this is actually really nice. So this is such a useful rule for solving triangles because it's really not difficult. Now the proof is clever the way that it works, but it's really a very usable tool throughout. Okay, let's see if I can find you something a little bit. Let's do this one here. But I think you're mastering this. I think we're almost done for tonight. Which of the 4 options do you think is correct for finding for the sine of A? So they're talking about the sine of this angle. Which of the 4 options do you think is correct? The y dash, that just means it's an angle. So that little hat always is just but it's not wrong to write y. It's just a sort of extra special recommendation that the y is an angle. But they haven't written it here. Like it would be equivalent to write a little hat on your A. It just means it's an angle, but no. So what is nice is it starts to feel kind of quite predictable in terms of the format. 11 sine 100 over 16. So it should be A. All right. Let's make this the last one of today, because I think you've done well. So it says, in triangle ABC, AC is 9 centimeters and CB is 7. Work out the missing angle CBY, which is sitting over here. And I want to see if you can think about how to use your knowledge from today to choose the correct option. And then I think, so Rafael said this topic is nice, but you have to combine. So there's 3 rules that we learn. And so it's all about combining the little rules together. It's kind of like in music, you know, like you learn a couple of notes or chords, and the chords by themselves aren't too bad, but it's changing between the chords that can be tricky sometimes and arranging them together. But yeah, there's nothing particularly bad about this. You just need to build a solid foundation. So I would probably, so they remix it. Yes, Kat, that's exactly what they do. And it can feel a bit cluttered sometimes. So that's why I like to start at the bottom and build a good foundation. I would find this angle first. I think that can help you. So what I really want first is the sine of ABC over 9. I'd probably start like that to give me the sine of 37 over sine of 37 over 7. Yes. And then what we then have to do is try and figure out what this is. But from this, we can work out what that is. So what do I get for my ABC angle? Who wants to help me out here? What do we get for ABC? I'm guessing it's an acute angle. It looks small to me. I have it from Okonele that we get 50.69. Would anybody else agree with that for the ABC part? And then to work out what this is angles on a straight line, which makes me think that CBY should be 180 minus this. And so let me use my calculator friend here, because I think it's the end of the night, so my brain is also starting to feel a bit like it needs a rest. 50.69 and 129.31, which means I'm going to get this over here. Yep. Now, just to point, yeah, okay, I'll talk about ambiguous case another time, but this is an example of that. Okay. Thank you, Hugo. The link to this week's quiz is in the chat. Please do this in the next 24 hours. It will really help you consolidate your learning. Today, we did how to use the sine rule to find sides, how to use the sine rule to find angles. And this is really, really helpful in the context of non-right angle triangles, because this rule works for all triangles in the universe. And so that's why we need to learn this in grade 11 to build on what we learned in grade 10. And then next week, what we're going to do is we're going to learn about something called the cos rule, which is helpful in other types of circumstances.